This video shows an example of implementing a one-sample hypothesis test in Excel. So here's the scenario. An internet service company wants to ensure that their mean upload speed for all their internet subscribers is at least 0.97 on a standard scale. So they take a random sample of 50 internet subscribers and measure the upload speed. And these are the upload speeds here listed in column A. The question is there evidence that the mean upload speed for all subscribers is less than 0.97? Okay, so first with hypothesis testing, we have to decide what the hypotheses are. So we have a null hypothesis and an alternative hypothesis. What is the question that's being asked? Is there evidence that the mean upload speed is less than 0.97? So we need a hypothesis about the population mean upload speed with a less than sign. Remember, the null hypothesis always has to have an equal sign. So either an equal, a greater than or equal to, or a less than or equal to. So we need one here with a straight less than sign. So that means it has to be in the alternative hypothesis. So the population mean is less than 0.97, population mean upload speed. Then the null hypothesis has to be the logical opposite of the alternative hypothesis. In other words, when you put them together, they have to cover all the possibilities. So the null hypothesis has to be the population mean is greater than or equal to 0.97. Okay, now we have what we need to start our test. The next thing we need to do is decide what kind of test we're doing. Well, we're doing a test of a population mean. There's two ways to do that. If you know the population standard deviation, you do a z-test. If you don't know the population standard deviation, you have to do a t-test. In this case, it says nothing about the population standard deviation, so we're going to use a t-test. A t-test is based on the t-statistic. Now I have it over here, formatted with white. In a t-test, you have a t-statistic, which is just the sample mean minus the population mean, divided by another term, which is the sample standard deviation divided by the square root of the sample size. So in order to calculate this t-statistic, we need to calculate the sample mean, the sample standard deviation, and the population mean and sample size are given. The population mean is the hypothesized population mean of 0.97, and the sample size is 50. All this t-statistic is how far from the population mean is the sample mean in terms of standard deviations of a sampling distribution. So this is a standard error calculation down below. So to get these, we need the sample mean, we need the sample standard deviation, and sample mean is just the average function on all these upload speeds in the sample. I use Control-Shift-Down arrow to select them. So there's my function, equals average of all those sample upload speeds. For the sample standard deviation, I use the standard deviation for a sample function, equals stddev.s, and then in the parentheses you select the sample values. So again, I'm going to put a formula over here so you can see the functions. So there I have my sample mean and my sample standard deviation. Next, we can calculate this bottom term, which is called the standard error. That's just equal to and we look at the formula up here, the sample standard deviation, which is this term, divided by the square root of the sample size, which is 50. We're told there's 50 in the sample. If we weren't told that, we could just use a count function to count how many were in our sample. So next we can calculate the t-statistic. The t-statistic is just the sample mean minus the hypothesized population mean divided by this standard error, which we just calculated. So it's equal to the sample mean minus the proposed population mean, or the hypothesized population mean, which is 0.97, and then divide that whole thing by the standard error term we calculated. So we get a t-statistic of negative 0.511. Next, we have to decide whether that t-statistic tells us to reject the null hypothesis or not. So let's do this in two ways. First, let's do the critical value approach. What will the t critical value be? First, there's only one critical value. Because the null hypothesis is that the population mean is greater than or equal to some value, we can only reject this null hypothesis if we have evidence that the population mean is less than. So if we have evidence for the null hypothesis. That evidence can only come in the lower tail, or the left tail of the t distribution for this t-statistic. Why? Because the smaller the sample mean is compared to the hypothesized population mean, this will be a negative number, and it'll be more and more negative, a larger negative number. And that'll be in the lower tail. So we want to find, does this tell us the alpha level? No. So let's set our alpha level to 0.05. Usually you're told what alpha level to use. This one doesn't tell us. So let's set the alpha level to 0.05. So what we want to find for the t critical value is we need to find the value in the lower tail of the t distribution. So we find the value in the t distribution that only 5% of the distribution is less than. Remember, the t distribution is a family distribution of distributions defined by their degrees of freedom. The degrees of freedom is the sample size minus 1. So what we need to do is find the value in a t distribution with 49 degrees of freedom, since our sample size is 50, that only 5% of the distribution is less than. So the function is equals t.inv 0.05, comma, 49. 49 is the degrees of freedom. And we get our t critical value of negative 1.67. So we will only reject the null hypothesis if our t statistic is less than the t critical value. It is not, so we fail to reject the null hypothesis, and we cannot conclude that the population mean is less than 0.97. Now, how would we do this with the p-value approach? Remember, the p-value is just a probability of getting a test statistic as extreme or more extreme as the one we got. Or in other words, a test statistic this far or farther from the mean of the sampling distribution of the test statistic that would occur if the null hypothesis were true. So in other words, on a one-tailed test where the rejection region is in the left tail, the lower tail, we have to find the probability of being less than negative 0.5114. And that is in a t distribution with 49 degrees of freedom. So our p-value equal to the probability of being less than the t statistic. So t dot dist the t statistic, comma, 49 degrees of freedom, comma, true. So this is just like the norm.dist function that we learned before, except for now we give it a degrees of freedom instead of a mean and standard deviation. So we get 0.30568. What that means is that if the null hypothesis is true and the population mean is greater than or equal to 0.97, we would have a 30% probability of taking a sample of 50 and getting a sample t statistic of less than 0.5114. Therefore, it's not so unusual that we got that test statistic. So we fail to reject the null hypothesis, just like we did with the critical value approach. So that's a quick overview of how to do a hypothesis test in Excel.